as promised, we're going to look at this example, which is a more complex one than the last one we looked at. This is a typical problem involving Hess's law, all right? So the question says you have to calculate the enthalpy change for reaction A, which is given right here. Let me go to full screen. All right, so this is reaction A, and it says you have to calculate enthalpy change, delta H here, given the data in the equations B, C, and D. So these are the equations B, C, and D, and their corresponding enthalpy change values, all right? So basically, I'm going to show you how to basically rearrange and transform these equations so that when you add them up, you're going to get this equation, and the resulting changes will result in you being able to calculate delta H. So what I'm going to do is get out of this here and go to my writing pad here. Let me get rid of this here. Okay, so you're given, I'm going to rewrite basically what you're given. You're given 2 carbons plus 2H2 gas to give C2H4 gas. And this is what you're trying to find delta H of, all right? Okay, so you're given, this is reaction A. Now for reaction B, you're given carbon solid plus O2 gas to give CO2 gas, and delta H for this is equal to minus 393.5 kilojoules, I'm sorry. And then in the case of reaction C, the equation is C2H4 gas plus 3O2 gas to give 2CO2 gas plus 2H2O liquid, and delta H for that is equal to minus 1410.9 kilojoules. And then finally, for D, you're given H2 gas plus half O2 gas to give H2O liquid, and delta H in this case is equal to minus 285.8 kilojoules. All right, so this is what you're given. So the first thing I would do, if you remember what I did in the simple example, I compared each of the equations for which the delta H values are given to the first one. So that's what I'm going to do here. I'm going to compare equation B to equation A. And when I compare them, the first thing I notice is that you have a carbon here in equation B on the left, but you have 2 carbons here on the left. So what I would do is multiply this equation here by 2 to get 2 carbons on the left from this equation. But you have to multiply the entire equation by 2, and you also have to multiply the delta H value by 2. So the result of that would be 2 carbon solid plus 2 oxygen gas to give 2 CO2 gas, and delta H for this is going to be equal to 2 times minus 393.5 kilojoules, which works out to be equal to 393.5 times 2. So according to my calculations, this works out to be equal to 787.0 kilojoules, all right? Okay, then I would compare equation C to equation A. And what do I notice? I notice that C2H4 here is on the left, but in equation A, C2H4 is on the right. So what I would do is flip equation C. And if I flip equation C, that means that the sign of delta H here is going to change from negative to positive. So in the case of equation C, after flipping it, I'm going to end up with 2 CO2 gas plus 2 H2O liquid. And then on the product side, I'm going to have C2H4 gas plus 3 O2 gas. And delta H, as I said before, will now become positive 1410.9 kilojoules. All right? Okay, and then now we get to the equation D. And if you compare equation D to equation A, you'll notice that you have 2 hydrogens here, 2 H2s on the left, but you have only 1 here on the right. So what that means is that I would multiply that by 2. So when I do that, I'm going to end up with 2H2 gas plus O2 gas. And then on the product side, I will have 2H2O liquid. And the resulting delta H value for that would be 2 times minus 285.8 kilojoules. And when I work out that, that would be equal to minus 285.8 times 2. So according to my calculations, this works out to be equal to minus 571.6 kilojoules, all right? Okay, so after doing that, the next step would be to add these equations together. And of course, when you add equations together, you cancel out those items that are common to both sides. So the first thing I notice is that I have 2 carbon dioxides here that will cancel out with 2 carbon dioxides here. Also, this one is not as obvious, but you'll notice that there are 3 oxygens here. You have on the right side. On the left side, you have 2 here plus 1, 3. So therefore, these 3 oxygens will cancel out these 3 oxygens, all right? What else? These 2 water molecules here will cancel out these 2 water molecules here, okay? And then there's nothing else to cancel, so we just write down what is left. And what is left is 2 carbon solid plus 2 hydrogen gas, right, to form C2h4 gas. And that equation here is the same as equation A here, which means that the delta H for this equation here that we're trying to find would be the sum of this value, and this value, all right? And that's because we added all these equations here to get this equation. So to get the delta H value here, we have to add the enthalpy changes of those equations. So let me do that now. 787.0 plus 1410.9 minus 571. Oh, shoot. Very important. I just realized that I missed a negative sign right here. Very important. So you see, you can miss a minor detail and that results in your answer being wrong. So let me do this again. It's minus 787.0 plus 1410.9 minus 571.6, and the answer I got is 52.3 positive plus 52.3 kilojoules as the answer, the final answer to this question. All right? So as I said before, this is a very typical Hess's Law type problem. In fact, I can guarantee that in your upcoming test, based on this topic, you'll get a question very much like this type. So I would strongly recommend that you practice doing problems of this type, including the problems that you'll get in your assignments, all right? Okay, we're going to stop here for today.